Factoring completely with the repeated use of the difference of squares formula. Again, it tells me to factor completely, which tells me I'm going to take out a greatest common factor first. This time I should be left with the difference of squares, which I'm going to end up factoring twice by the time I'm done. But if we start here with our greatest common factor, 32 and 2 are both divisible by 2, and they both have a u squared that I can take out. So if I divide by my 2u squared, 16 here, and minus v to the 4th is what's left over on my second term. So both of those things should be perfect squares when you factor that out. Not that on the assessment it's going to tell you that you're doing this problem, but while you're doing it. This will be the difference of perfect squares. Factors of 16, 4, and 4. Factors of v to the 4th would be v to the 2nd and v to the 2nd. One has a plus, one has a minus, and of course the 2u squared is out in front. You cannot factor the sum of perfect squares. Try as you may, you'd have to have that third term in there because you'd have to have the middle term from FOILing it out. So you won't factor the 4 plus v squared, but then on the end you do have the difference of squares, which are going to have you factor a second time. So factors of 4, 2 and 2, factors of v squared, v and v, and of course one has a plus and one has a minus. So 2u squared times 4 plus v squared times 2 plus v times 2 minus v would all have to go in for your answer once you have it factored completely. So number 14 there, if I take out my greatest common factor would be 2x to the third, 2x cubed. And if I divide that out, I'm going to be left with u to the 4th minus 1. That doesn't cancel out and is gone. It has to be there because if I use my distributive property and there wasn't anything there, I just get my first term and I wouldn't get my second term. But again, you can see we have the difference of perfect squares. U to the 4th minus 1 factors into
squared plus 1.
U squared plus 1 and u squared minus 1. Again, we can't factor the sum of squares, but we would factor that difference of squares. So u squared minus 1 factors into plus 1 and u minus 1. So we get 2x cubed times u squared plus 1. Whoops, I don't need that parenthesis there. What am I doing? So 2x squared times u squared plus 1 times u plus 1 and u minus 1. And number 15 again says factor completely. The greatest common factor there would be
X to the third.
X to the third. If I divide out my x to the third, I'm left with (81 minus u to the 4th). And so if I factor my difference of perfect squares here, 81 minus u to the 4th factors into 9 minus u squared and 9 plus u squared. And then if I factor the 9 minus u squared, that's going to factor into
3 plus u.
3 plus u and 3 minus u. And of course we still have our 9 plus u squared. Now we have the commutative property, so it doesn't matter which order you have all your factors in, just so you have them all.
Your x has to be cubed, so.
Whoops, my x has to be cubed though. Good catch. X cubed. See, that's what happens when I move over instead of down.